Today we're going to talk about multiplying and dividing with scientific notation. So we're going to start out with multiplying first. So you'll see an example here, 4.2 times 10 to the third times 2 times 10 to the second. So we've already learned about our exponent rules. So these have like bases, 10 and 10. So what we're going to do is we're going to multiply the numbers by the numbers. So we're pulling out 4.2 and we're multiplying it times 2. So you could use your calculator for this point or just do some quick multiplication yourself. And we see that we get 8.4. Okay, so the numbers have been taken care of. Then we're going to multiply the 10 to the third power times the 10 to the second power. Well, these are like bases, so we can keep the base. And we add when we're multiplying exponents together. And then we check, is this in scientific notation? Yes, this is in scientific notation. We have one place value, that's 1 to 9, and then we have 10 to the fifth, so this would be your answer. So let's try another example. So example B, 5.4 times 3. So we're going to pull out 5.4 times 3. Again, you can do it longhand or with a calculator. We're going to do this one longhand. So we have 12, carry a 1. We have 15. 3 times 5 is 15, plus 1 is 16. Bring down your decimal. And then we're going to use 10 to the third power times 10 to the second power. Like bases, we keep. Add our exponents. So 3 plus 2 is 5. So then we ask ourselves, is it scientific notation? It is not. We have 2 place values and we can only have 1. So we're going to move that place value 1 and we turn that into 1.62. So did that number get bigger or smaller? Well, it got smaller, which means our exponent must get bigger by how many places we moved. So we only moved 1, so this would now be times 10 to the 6th power. That would be our final answer. Let's go on to example C. So we have 92 and 4. 92 times 4. 4 times 2 is 8. 9 times 4 is 36. We have 368. And then we have like bases of 10 to the fifth power times 10 to the negative 3. We add these together, keep our base, 10, 5 plus a negative 3. So 5 plus a negative 3 gives us 10 to the 2. So we have 368 times 10 to the 2. Is this in scientific notation? No. So our decimal is here. We only have to have one decimal place. So we're going to move this 2 places. So 3.68. Our number got smaller because we moved it 2 places. So this has to get bigger by the number of places we moved. Well, because we moved 1, 2, we have to add 2 here. And this becomes 10 to the 4th. All right, example D. Try this one on your own and see. Pause the video and then see if you got it right. Okay, so we multiply here 0.018 times 1.3. When you multiply, remember with decimals, you multiply it like normal, ignore the decimals, then you count how many spaces. We had 1, 2, 3, and 1. So we have to move our final one over 4. So 1, 2, 3, 4. So our final answer is a decimal 0.234. Because we are not in scientific notation, we have to move this 2 places, and the number got bigger, so this number had to get smaller. So we take away 2 places. So negative 1 minus a negative, or with a negative 2, we get a negative 3. So this is our final answer. So see how you did. Now let's go into dividing. Dividing is exactly the same way, except we use our exponent rules. When we divide like bases, we subtract the exponents. So we're going to look, and I went ahead and set these up on top of each other. So 12 times 10 to the fifth divided by 4 times 10 to the second. 12 divided by 4 gives me 3. I have like bases, so I have 10. 5 minus 2 gives me 3. Check, is it in scientific notation? Yes, it is. All right, let's try example B. So we have 5.3 divided by 7.65. You could use your calculator here. 5.3 divided by 7.65 gives us a very large number. So we have 0.69 0.28104575. Huge, actually very, very small number because it's a fraction, or less than 1. And then we have 10 to the third minus a negative 5. Two negatives make a positive, so we have times 10 to the 8. We say, is this in scientific? No, it's not. It needs to go over one spot. So we have 6 point, and we have to write everything there because it's not zeros. They're all there. They have to be written. And because we got bigger, this exponent has to get smaller. We move one place, so it has to get one smaller. And this will be our final answer. All right, let's try C. All right, I want you to try this one on your own. Pause the video, then come back and see how you did. All right, here's your final answer. How did you do? All right, you have some practice problems that you need to do. If you'll look on Canvas, you'll see your assignment.